everyone! Welcome back to integralcalc.com. Today we're going to be talking about how to calculate second order partial derivatives. And in this particular problem we've been given the function f of xy equals x squared plus e to the y squared. So notice first of all that we've got a function in two variables. We have both the x variable and y variable involved in our function. And remember that if we're going to calculate the second order partial derivatives, we'll need to calculate the second order partial derivative with respect to x, with respect to y, and the mixed second order partial derivative. Now, in order to calculate all three of those second order partial derivatives, we'll first need to calculate the first order partial derivatives because the second order derivatives build off of the first order derivatives. So for this video, I'm going to assume that you have at least a basic understanding of partial derivatives and that you know how to calculate the first order partial derivatives, but of course I'll go through these steps as a refresher. So the first order partial derivatives are going to be partial derivatives of f with respect to x and with respect to y. So we'll calculate the partial derivative with respect to x first. Remember that when you're calculating the partial derivative with respect to x, you're treating x as the variable and you're holding y constant. You're treating it like a constant, like it's a number, like 2 or 4 or something like that. So when we take the partial derivative with respect to x, we'll go term by term. So taking the partial derivative with respect to x of x squared gives us 2x, right? Nothing fancy there. With respect to e to the y squared, there's no x variable involved in that term. We're treating y as a constant, so ey squared just becomes 0, right? Because there's no x variable involved there. So this is no different than saying, plus 4. We treat y as a constant. This is a constant number here, and so there's no derivative, or I should say the derivative is 0. So that'll go away there. The partial derivative with respect to y, again, term by term. For the first term here, x squared, there's no y variable involved in that term. So the derivative there is going to be 0. But with respect to e to the y squared, we'll have to take the derivative with respect to y. So remember that when we're taking the derivative of e to the x, the derivative is just e to the x. So similarly, the derivative here will just be e to the y squared. But we need to apply chain rule and multiply by the derivative of the exponent y squared. So the derivative of y squared is just 2y. So we go ahead and multiply by 2y. So now we see that these first order partial derivatives are equal to 2x, and the one with respect to y is equal to 2y e to the y squared. All right, so we've got our first order partial derivatives, and now we need to go ahead and calculate our second order partial derivatives. So I'll go ahead and over here write the second order partial derivative with respect to x, and then the notation looks like that. And then with respect to y would be y squared, like that. So calculating second order partial derivatives, all we're doing is taking the derivative of the first order partial derivative. In this case, because we took the first order partial derivative with respect to x, here we're going to take the partial derivative with respect to x again. So we're going to take this value here and take the derivative with respect to x again. When we do that, the derivative of 2x is just 2, so the second order partial derivative with respect to x is 2. And then same thing here with y. We took the first order partial derivative with respect to y, and we got 2y e to the y squared. To calculate the second order partial derivative with respect to y, we're just going to take the derivative with respect to y again. This time we have to use product rule, where we have one function equal to 2y and the other equal to e to the y squared. So remember that product rule tells you to take the derivative of one function, multiply it by the other one, and then add to that the derivative of the opposite function multiplied by the original opposite function. So what we're going to do is take the derivative first of 2y, which is going to be 2, and then we'll multiply that by e to the y squared. Right? So we took the derivative of this one, leaving the second one alone, and then add to that. This time we'll leave 2y alone, but multiply by the derivative of e to the y squared. Well, we already know from the original problem, right, that that's 2y e to the y squared. So when we simplify this, we'll get 2e to the y squared plus 4y squared e to the y squared. And if we wanted to, we could go ahead and factor out a 2e to the y squared, but we don't have to. But we would get 1 plus 2y squared. So either way, both of these are correct, either one, factored or not. So we now have our second order partial derivatives with respect to x and with respect to y. And now all we need to do is calculate the mixed second order partial derivative. And what that looks like in terms of notation is the second order partial derivative of f. This time, instead of x squared or y squared, the notation looks like this. And what we're going to be doing, remember that here we calculated the first order partial derivative with respect to x and then x again. And here with respect to y and then y again. When we do the mixed derivative, we can do it either one of two ways. We can take the first order partial derivative with respect to x and calculate the derivative of that with respect to y, or we can take the first order partial derivative with respect to y and calculate the partial derivative of that with respect to x. So we're just flipping the variable that we're using. So either way, this one with respect to y or this one with respect to x. It's your choice, and this is a good way to check yourself because regardless of which one you use, you should arrive at the same answer for the mixed second order partial derivative. If you don't, you've probably done something wrong because they always have to be the same. So I would always recommend choosing the one that looks easier. Obviously, this one here looks easier to me. All we have to deal with is 2x instead of 2y e to the y squared. So let's take the derivative of 2x with respect to y. Well, the derivative of 2x with respect to y is just going to be 0 because there's no y variable involved in the function 2x. So the mixed second order partial derivative is just 0. Notice that if we took the derivative of this with respect to x, since there's no x variable involved in that function, we would also get 0. So either way, this is good news for us because we've confirmed that these two match, which is what we want. So we could have done it either way, but we chose 2x because it was simpler. So again, when you're talking about second order partial derivatives, you want to calculate all three: the second order partial derivative with respect to x, with respect to y, and the mixed second order partial derivative. So I hope that video helped you guys, and I will see you in the next one.